Nowadays, metrics are available everywhere. We are meeting it in every single day. The sellers has to supply their quotas. Workers on hotlines, they have other metrics. We are setting the goals. Goals are another metrics, which helps us to get a raise, promotion, get a bonus. The very same goes for our application. On DevOps conferences, people are talking a lot of metrics like DORA ones. And we can think, yeah, it's important. We should think about the metrics like lead time for the changes. So the time which elapses from the moment when someone requests the new change in our code till the moment when it's deployed to the production. But actually, I think in the JVM world, we have a much more crucial troubles. The one of them is the startup time of application, because we need to run our application in interpreter mode firstly. And yeah, it's a pain. Okay, my name is Michał Rowicki. I'm working for Paramount, and this presentation is made based on knowledge gathered there. We have a couple of interesting projects there. Nice team, I think, wink wink. And that's it, we can go further. So, first of all, I don't think once you gather there, you know why it's worth to optimize startup time. So, we have a couple of types of application which actually don't work correctly in the JVM world. For example, there are applications which works like a couple of minutes and then waits for the next traffic. Maybe it's like a message on queue, and because by this message, we need to rebuild our cache. So in this example, we have application which after startup do some work, saves to the cache and waits for the data. So what's the issue to turn it off? Maybe it's the long startup time, because if we need to wait like 1 minute when it's go up and running, our data will be stale on production for this minute. But if we will work with the startup times, this data could, this application can start almost instantly, and we can update caches and don't spend the money for no usage time. The very same goes for the other use cases, for the application which are working for the back office. So only when the people are in the work, like since 8 a.m. till 4 p.m., there is a need to open this application. And this kind of the application, even if they are open on bare metal, so, this is often, but they are not turned off for the night, because maybe they are unstable, they are starting long, and that's another case which should be improved. And the last, or it's not the last, but very important, like for me, high availability applications. So if you can imagine that your service in the particular date receives a surge of requests, like for us, it's, for example, Super Bowl event. So we have like hundreds of millions users. So yeah, we can, maybe we shouldn't care about the startup types. We can upscale, but people are not good in the statistics. Even if we had a traffic X in the past year, and we can estimate that we will have 20% increase the next year, maybe we will make a mistake. Maybe there will be need to add more our services to allow user see the show. So it's another case when we should struggle for the startup time. If there is a higher traffic, the another service should start very fast. And last topic about the sustainability. I can see on IT conferences there is a lot of talking about the being eco, not producing a lot of CO2, but you know, IT industry don't produce a lot of CO2. The more important here is cheaper hosting. We should collect the data and show our business to get a raise, I think. And when we are deploying our application to the Kubernetes, to the other cluster solution like AWS, ECS, Maybe there are solutions made by Golang which are starting immediately, and they are small, tiny, nice. So we are looking like this bastard who produced the slow service which starts very long and it's very heavy. So it's better to think about that. And all of these subjects goes into the term per for use, because it would be nice to scale every our application to 0 and start after that it like by Azure Function or AWS Lambda. And where you should start? From my perspective, mostly we are digging our own grave for yourself. And the mistakes are made by us. So first, we can start with async profiler, with the event. Oops, it started again, not this image. With the wall clock mode, which will check every thread with the same rate, and it will show us how fast application is starting. I don't know if you see correctly, but underneath there is a flame graph, and based on this flame graph, with total time, we can see where our application spending times. Like here for the minimal application, mostly we are spending time starting new threads, system ones. Okay. So maybe first we can get to each other. How many of you are using the Java 8 or below? Okay, there are some of you. I hope it's 8, not below. Below, oh. There wouldn't be a lot of things for you, but I hope maybe it will be the arguments to points to upgrade it. How many of you are between 9 and 11? Okay, there are some. Above 12 till 17th. Okay, and about since 19 till 21. Oh, quite a lot. And someone on bleeding edge, 22? Okay. What about Spring Framework? Are you using the Spring Boot 1.x? Is there anybody here? No. Is anybody out there using Spring Boot 2.x? Okay, and 3.x? Okay, quite a lot. I'm asking about that because this presentation is made in the form when the first slide shows the solution which can be used in the old Spring Boot, in the old Java versions, and as far we go further, you will be more tired. There will be the more stuff which is talking about on the conferences nowadays. But I think it's not very handy for most of us. So first of all, I don't want to speak about the worst. I will speak about the containers and jars because I don't have big experience with deploying with the worst. And about the containers. Mostly nowadays we deploy our application with the containers. And that's not a very popular fact, but the size matters. And if you think about your network interface, if you have like 10 gigabits per second throughput, so maybe if your image weighs 100 megabytes, it should be pretty fast to deploy this image. Very fast calculation, 80 milliseconds. It shouldn't care, yeah? So here you can see some data from AWS ECS. You can collect the very similar data by the Kubernetes ready time, comparison with the startup application time, this log line which appears in the logs when application starts. So what we can see here, first of all, we should read it from down to up. From some trigger, AWS ECS decided to add additional node of our application. It happened, we should look at this number, 59 seconds. It took 5 seconds, about 5 seconds, to find a node feasible to run our application. And then, between started and registered task, there passed about 90 seconds. And during these steps, actually on the node, we are pulling the image. And image, for this case, weighted 250 megabytes, quite a lot. And the last lock is 43 seconds, and so we can see these 20 seconds, they are perfectly fit with what is locked by the application, like Spring Boot startup time, it's blah blah 20 seconds. But it's quite a huge this part, which we should concern. So it seems like 250 megabytes in 19 seconds. So 100 megabytes is not passing through this interface, which can handle 10 gigabits per second. It is not done in 18 seconds, but with simple calculation, we can estimate that it takes about 8 seconds. 2 orders of magnitude bigger. And we shouldn't be surprised, because this interface is probably used by the other application. We cannot use all the bandwidth and kill them. Moreover, we have underneath the TCP, and from the very beginning, we cannot start with the high bandwidth. The window will widen or shrink based on the TCP retries and other issues in the network. So that's why we should struggle for minimizing image size of our application. Sorry for this slide, it's not very readable, but I find it very nice. It's produced by the Liberica. It's one of the JVM vendor, and they show the very nice decision tree, how to choose the best JVM or JDK development kit or runtime environment for our purposes. And we can see here that the smallest one weighed about 70 megabytes. Quite not bad. And are you familiar with Project Jigsaw? Is there anybody who knows? And anybody who uses? Yeah, I know. Project Jigsaw was introduced in the Java 9, and it was about modularizing the JVM. For what the sake, use the JDK or JRE with all modules when we don't use them. Maybe it would be better to push to the production only subset of these modules which are needed by our application. And JLink is the tool which can produce the JVM with the subset of these modules. So on the right side we have some produced modules for the basic Spring Boot application, the modules which was discovered by another tool, JDEPS. On the left, we can see the long list of all modules of the JVM. One of them are tiny, one of them are thick, but still we can save some space of our image, cutting it down. So I use it, and I built an image, and I realized that my image was 106 megabytes. And it seems like a bit bigger than this one shown by Liberica with all modules. Do you have idea why it happened? You forgot field text. Not really. I didn't forget. It wasn't that case. Okay, then I downloaded this small tiny image, and I saw that the JVM weighs there 158 megabytes. So that was my mistake. When I uploaded this image, I realized that this smaller JVM prepared for my purposes, it's only like 40 megabytes because ECR compresses. ECR image repositories compress them. So you can have the very same issues, so that's why I would like to show you. Okay, we talked about how to accelerate the startup time by shrinking the JVM. Another issue is architecture. How many of you are using AMD 64 architecture in production? Yeah, quite a lot. So, even if you are using it, so for your choosing of base image, you look for the images which are supporting for both architectures, like AMD 64 and ARM 64, because if you will get the guy with the ARM processor, it can work with the very same JVM. It won't be the other one, and there could be the other bugs. So it's better to work on the very similar software. And moreover, someday you can deploy your application to nodes with the ARM architecture. Thanks to that, you can, for free, use less energy, pay less for them, and it's gain for nothing. And there is some work in a Spring Boot team which is going to remove dependency to some modules. And there you can see the ticket, which is open quite long. So it's about 3 years right now. But there was some sub-tickets which have been fixed, and they removed the basic dependency to the module Java Desktop, which is quite heavy. It has like all classes for AWS, for displaying window on different platforms. But if you would like to do that, you need to go to this ticket. I recommend give a reaction, because I think it's not closed because people are not interested with JLink and they don't connect the points, but it can improve their startup time. I will share this presentation after the meeting on the meetup, or Sebastian, I think, will share it. Okay, first demo. What's going on? Okay. So, for sake of today's demos, I created, like that. I created very simple application made with Start Spring.io. So there is nothing. It uses Spring Boot 3.2.0 version. There will be 1 or 2 examples with release candidate for 3.3.0. And for the sake of this first example, I would like to show you how to build the image. And that's very interesting, because I tried to do it with the different images like Amazon Corretto, which should be optimized to work with ARM architectures, but it didn't work. So JLink had different issues. The very same happened with Microsoft JVM. And finally, Temurin was the one who could prepare the JVM for Spring Boot application. So what we can see here, we have built it, probably, if I built it previously. Yeah, there is. We don't need this one. Application, which we are passing to the Docker. Then we are unpacked it, and then we will use the JDEPS tool, which will look for all dependencies, like modules of the JVM, and will pass it to the file deps.info. And after that, there comes JLink, which uses those modules and creates the image. So let's try to run it. We'll see if my internet works. Yeah, it works. Okay. In a while, we will see this produced JVM. So we are removing here the debug information from JRE produced, header files, manual pages. We are compressing the output. Moreover, there is one module, local data. So even if we are using it, and we are using it for the two languages, we can shrink other languages which are not supported by our application. And moreover, we can go into our JRE and look into the files. If there are some files which we are not using, like there is some binary JRun script which I'm not using, you can exclude it. And after that, it's a multi-staging build. On the Alpine, we can just pass our Java Runtime Edition, and after that, we can start our application. So as you have seen before, it started, and it was like on the Java 21. And next, about the image. Show layers, analyze. Okay. Here we can see that our image weighs 57 megabytes only. And we can, for example, remove JFR key tool if we don't use, and so on and so on. So that's the first step to accelerate our application. So when we finished with shrinking size of our container with JVM, we should look into our fat jar. Maybe there is something to do with improving of its startup time. So right now we'll think about this time of this one, which is logged by the application when it's starting, not about transmitting through the network. Or maybe we can do something with size. We'll see. Oh, it's not visible very well. Okay, so starting our fat jar is quite complex, because when we run java-jar fat jar, underneath, it's not called directly our application with main method, but we start firstly jar launcher, which is responsible to first replace system class loader with the one called URL class loader, because system class loader cannot read these Matryoshka style jars when you have jar into the jar. And moreover, JVM doesn't know how to handle URLs when you have nested jar in the jar. So after that, we need jar URL connection, which uses URL stream handler, which is responsible for handling these URLs. Yeah, quite a lot of work. And just after that, we are going to the start class and entry our application with the main method. And this is how it looks based on the documentation of the Spring framework. We have inflated jars, these Matryoshka style jars, and they are inflated. In common language, it means they are not compressed. So we don't spend a time on compressing these jars when we would like to access one or another. Okay, here, if you someday will debug some issue and you will meet this kind of the URLs, it means that we have kind of class loading which should be done by URL class loader. And next, there is some issue. If we will have problems on this very early stage of running application and we go from our IDE into the manifest, we'll see that the jar launcher, which is responsible for start our application, is not available on our class path. That's because Maven plugin and Gradle plugin are adding on the building process these dependencies to our application. So it's quite difficult to just put a breakpoint in the jar launcher, which we don't have. So what to do in such situation? First of all, you need to look for your favorite series, maybe a movie. Just before starting watching, download the Spring Boot, open it in your IDE, wait until it will be indexed. It will take ages. And just after that, when you finish binging your serious, you can look for the class jar launcher, put a breakpoint on the main, then start your fudger with this flag, which will cause stopping application before starting until the remote debugger will be connected. Then you can figure out what's going on with your fudger application. And what can go wrong? It happens often that people run the application from the IDE. And IDE, when runs a Spring Boot application, it uses random class path order. And it's a kind of the problem, because Spring Boot 10 years ago was built to avoid issues with running application with random order of the class path. Because we can imagine that there is one class which looks for, which uses the method for name with the string for the class, which is not already on the class path. And then we have the issues when our application doesn't work on our machine, but work on the production and otherwise. And this kind of the issues was already not once mentioned in Spring Boot issues. So it's better to make tests against the FATJAR to avoid issues. It works on my computer. But that's not all. Unfortunately, JDK is not aware of custom URL class loader. So when we are using tools like JShell, JDEPS, they cannot use this custom URL class loader. They are trying to use system class loader, and they are failing. Moreover, some Java agents cannot load some classes because they are trying to do it by system class loader. The very same going for the Java util logging. And I think that's it here. And so what we can do in our code? First of all, we should avoid calling the system class loader. Then, for the some tools from the JVM, there are wrappers, like JShell wrapper, which can use the URL class loader. We can just unpack the FATJAR, and we can unpack some particular libraries. Here is a snippet for unpacking them. I wouldn't like to go deeper into this, how to write it, but what is important here is that I suspected when I will write that I want the given dependency to be external, there will be external file next to my FATJAR, but it's not the case. It's happening during the runtime. Spring Boot starts, and this part of the code which starts before our main class unpacks the jar file into temporary folder, and it can be loaded from this place, and also it changes our class path on runtime. And finally, unfortunately, FATJARs are slower. That's because of Spring implementation of class loader. It's not optimized to the point as it is optimized by the JDK team, JVM Java team. And here it's visible better. If we run our application from IDE, it's like rough data. It's not like a big benchmark. It's quite fast. When we run with boot run task from the Gradle, it's even faster. And when we run our FATJAR, we can see, yeah, it's slower. Jar launcher, it's slow again because it's doing additional work which we are not needed actually. And finally, running our main class gives the best result. But always there are buts. When we run application from our main class, we are losing the metadata from manifest. Moreover, we need to specify in command line start class. And order of the class path is random. So we can go into the troubles which I mentioned before. So what we can do, we can write handmade script. Remember how it was done in the early days of the Java when we didn't get the fancy tools to run application. And Such tool was being developed by Sebastian Deluze from the Spring Boot team in scope of class data sharing mechanism. But unfortunately, it doesn't support the files like for the actuator, the other resources. So I improved it a bit, and it is fast as running the main class, but we are getting all of these benefits. And you can do it on yourself if you don't run on the bleeding edge of Spring Boot to use some fancy tools, which we'll see later. And why to do that? Why to use the custom script or to run jar launcher? If you are familiar with actuator, it shows, for example, a version of application, and it is included in the manifest file. Moreover, it could be visible on Spring Boot admin if you are using, or Swagger. So that's why it's important to pass it, to know what is in the production. If we have issue, we should know if we have some rollback or not. And all of these topics, which we covered lastly, are very close to the developed containers. This is the tool made by Microsoft, which aim is to running on the very same operation system, with the very same runtimes, shared libraries, our application from the very beginning. So we should start locally IDE in some container, like for the Linux, even if we are using macOS, Windows, to have the very same system, to tackle down issues early, not on the production. Because sometimes, even for the CIs, we are using the other JVM, we are using the other system, and it's important to be as close as possible to the production from the very beginning. And lastly, I think it's half of year, the support for the dev containers was added to the IntelliJ. So I recommend to use that. Unfortunately, I don't have a demo today, but it goes the same, like running FatJar, like we can run from the IDE, or you can imagine that you are producing some smaller JVM and it fails on the production because you use the other JVMs for testing, like for some integration tests. Okay, another demo. It's not there. Okay, can I make it bigger? Haha, it doesn't affect the...
You can open in...
I don't want to open it in the presentation mode because it crashes my Mac every time. Yeah, so yeah, I like Macs, you know. So let's try to zoom it. Can you see the code? Okay. So first, clean up the project. And if we would like to unzip the file, a jar file, and run it through the jar launcher, there is this command jar xf. And then we are starting application, and we can see there is information about the version. Okay. Then we can run our application with some random class path, finding our start application. So it started, I think, a bit faster, but it doesn't very important right now. But we are missing the data about the version. Okay. Okay, I stop this one. And finally, there is a script, unpack executable jar, which will unpack our application to the directory unpacked, and it points to our fat jar. Then we are going to our unpacked jar, and we are starting the application. So it takes some time, and start our application again. And when we go to the unpacked application, we can see there is a run up file with the manifest, which has the class path taken from the original class path, from the, where is the libs? Let's go here, bootinf, and here we have the file class path idx. So here we have like annotation, Jackson annotation, and here first is going our code, and then we can see there is annotation, Jackson annotation. So we have the very same class path. We have somewhere there information, we should have there, yeah, it's over there, information about the version of application. And here we have some of our dependencies, which are next to the application. Okay, that's it for this part. And let's continue. So up to now, we discussed how to minimize the image size. We discussed how to unpack our fat jar to get some acceleration, maybe not a huge, but still it's some improvement. And then we can go back to the images. Basically, when we pull an image to our system, we can see there is some kind of the cache. And with every cache, we have the issue of its invalidation. But here you can see some example what can happen on the production. Actually, we can have some basic image here for Golang. And after that, we can copy some, let's say, big layer. Maybe it could be as big as some binary made by the GraalVM, like 100 megabytes. And then we are passing entry point. And both of these layers is taking time to transmit it through the network. Do you have idea how can we make this process faster? What we can do that there? Okay, what we can do basically, we can try to slice server. Maybe we can slice dependencies somehow. And some of our services can use the very same dependencies. And mostly what we are changing is the application code. So if we can deploy the new version of the application on the very same server node, the upper layers could be taken from the cache if there is application running on this node. And that's what was introduced like 4 years ago with Spring Boot 2.3 to 0.0. They added option for layering the JVM, not for the Golang. But before we go there, some knowledge about how we are building images. When you write this Docker file with commands, actually what you are getting from the from is the image. Then when you install somehow with some package manager, Java, it actually runs container. When the commands finish, it makes a snapshot of this container and it's an image. And then it makes a command commit, stops the container, and the next commands are running. It will be important. We'll talk later a bit about the CRaC and some intricacies and problems with building these images. So it's reading up to down, yeah. And what we should think of creating images which have bottom layers which change rarely and maybe when they can be reused between the different teams. So on nodes of our which runs our application, there is a chance that we will minimize the amount of data which will be transmitted through the network. And maybe we can transmit only our application data if we don't change any dependency. I think it happens quite not so often. And another thing which will come as handy for us, we saw it previously for Docker files for the jailing, we can have multi-stage Docker files. So the first part of this Docker file builds our application on the given system, and based on this build, in the second Docker file, which starts with the from clause, we can copy only the results. So there could be at the very same operation system, and this one can have like just only Java runtime edition, and above one can have the full JDK. And finally, layered jars. There is a command for the Java jar, the mode layer tools, which allows us extract fat jar into the layers. There is directories, produce directories with the old dependencies, Spring Boot loader classes, snapshot dependencies, and that makes sense because snapshot dependencies changes more often. So probably this layer will be changed more often than above ones. And the last one, application with our code. And this information we saw previously a class path IDX, and here we are seeing layers IDX. Layers IDX describes how these layers should be prepared. And moreover, we can customize these layers. As I said previously, maybe different our teams, different services reuses the very same core libraries in our company. So then maybe every single node which is running any of our JVM application will have these layers. Moreover, if we are using the very same base image, like the same JVM. And here as well issues, because maybe we are using the very same libraries, but if we don't produce reproducible builds, the checksum for the very same layer can have the different sum, because we can have different modification dates. We can have, for example, we can save into our jars times. Mostly there is a times of build time, or the paths of the environment which built the application. Mostly reproducible builds are talking about when we are talking about the open source, but it goes the very same when we are building the images with the Docker. Okay, so the next example, how to set Duke. Reproducibility. Later I will give you the link for the repository, so don't worry about the links. And first, another time actuator. Actuator has inside it, if you enable the actuator info endpoint, the information about the build time. So there are tools which are advertised as they are producing reproducible Docker images, but they are not until you disable information of the build time. Instead of that, you can include the time of the commit which was made before merging to the master. So here is the snippet for the Kotlin Gradle, Groovy Gradle, the very same for the Maven. And the next thing, and that's pity, it's not documented in the Spring Boot documentation. There was tickets previously about reproducibility of fat jars. If you would like to have our fat jar reproducible, first of all, we need to pass two flags. One, to preserve the timestamps, and they set timestamp of every single file in our fat jar to the 1st February of 1980. I don't know why this one. It's not a start of the epoch, but there was some decision. And order inside the fat jar is not changed, because even if we see inside the fat jar, this order seems to be every time the same, but actually it could be different. It's only sorted by the name. So thanks for these two flags, everything inside this jar could be reproducible, but the name, this file, has a modification time with the current date. So we need to add additional couple of lines of code to, after the task, touch this fat jar and change its modification time. The very same goes for the Groovy Gradle. In the Maven, it's a bit easier because there is a plugin to make the jars reproducible. And next, custom layer definition. It's over there. Provided by the Spring Boot layers are not the best ones, I think. You need to configure it and discuss it with the other teams which are producing services in the JVM. But I think it could be done differently. We can add like additional layer core for every dependency which is produced by the Spring team. Another layer should be created for the managed dependencies by Spring. That's, for example, maybe at your place it will be different. And after that, you can set order of all of these layers from the ones which change very rarely to the ones which change very, very often. And Dockerfile is very similar to the one which I show in the presentation. So we are unpacking our fat jar and then we are copying layer by layer to the produced image. And here is a bigger chance that it will be reproducible and we can reuse it between the projects with the core dependencies and so on. I won't run it. Okay, and there are tools which are advertised to make a lot. One of them is a build pack, and it is used to produce as well reproducible builds. It from the out of the box use these layers. We don't need to know everything about that. But you know, I think this is like leaking abstraction, because after that, if something doesn't work, you need to learn everything about the Docker files, you need to dig about it, and then you need to learn the intricacies of the build packs. So I don't want to show you the examples. Even the documentation is not very well for the build packs. Other tool, which is advertised as the one which can produce the images. What time I have? Okay. Is the JIP. This one is nice. Of course, it adds layer of the abstraction, but it gives the very nice feature that it doesn't need Docker daemon. So, if for the some sake your DevOps team wouldn't like to provide you workers with the Docker daemon, you can use the JIP and produce images as a tarbles or push to the different repositories without the Docker. So this one is from my perspective, it gives a value instead of the build packs. Another demo. Oh, if you have any questions, don't hesitate to interrupt me. Okay. So with the JIP, we can build image very fast, pointing our jar. It's the one of the option. Of course, we need to remember all of these flags. We need to install JIP CLI tool. The other option is to define everything in the YAML file, and then we need to use command build. With this JIP YAML, we can define architecture of the output image. We can define if we would like the format of Docker or OCI. We can define the number of the user, because most of these examples which I'm showing to you, we are running everything with the root user. It's not very safe. It would be nice to remember to change that, but most of the people are forgetting that. Then we can set properties for the layers, what groups should be used for the files. And finally, we can define all of these layers, like dependencies layer, Spring Boot loader layer, and layer with our application. This is the second option. And third one, it's writing everything that in the Gradle. With Maven, you need to write your very own plugin. It's possible, of course. So, first of all, you need to write a task for extracting layers. You need then connect it with the JIP tasks. And after that, you can provide all of this information. I don't want to go deep here, because I think it's pretty straightforward. But if you are in that problem, but you don't have a Docker daemon on CI workers, yeah, it's nice to use that. Okay, so I think I don't need to dig into comparison. I am very opinionated of using and crafting our Docker files. Maybe for startups, build packs are fine. When we don't care about the startup time, we don't have a time to figuring out how to do everything well. So it's a good start. And the JIPs are for these ones who don't have a Docker daemon. That's my personal opinion. And when we finish these things, we should talk about the class data sharing. Class data sharing actually was introduced in the Java 6 as a Enterprise Edition feature for users of Oracle. Oh, I think it was a Suntime feature, which was paid. It was opened in the Java 8. And what is doing? There was a thing why we need to load all the classes every time, the metadata. Like there is in the metadata signature of all methods, signatures of all fields, of pools, like the all strings which we are defining in our files. There is no point to load it every time when we start our application. We can get it into the memory, then dump it to the file. And in the next start, we can reuse this file. And with the Java 10, it was extended to allow creating the builds, to creating an archives with class metadata for our classes. But it was very troublesome. We had to first create the list of all classes. And after that, we had to reuse it in the another run of the JVM to create our application CDS. That's why it's nice to have at least Java 13. And here it's possible to do it with just the commands to create this archive for our application. So first we need to add flag which informs where to dump our metadata of classes when the application stops. And after that, we can reuse it to start application a bit faster. And when you are starting to using the application class data sharing, you definitely should look into the JVM logs for loading classes and CDS logs, because it can result that you are using nothing. So it's better to use. There is the link for the CDS log parser made by Stefan Nicol. And again, what can go wrong? Class path reordering or Spring class loader. What can go further? We can use Java agents, which are modify on runtime our classes. So if we change a class, we will add the additional method. Again, cache invalidation, we cannot reuse it. Yeah, and that's how it looks, our work. Again and again. And if we go to the CDS, it's very worth to update the JVM. Like, for example, Java classes compiled to before Java 6, which are very common, actually, in our libraries, because these libraries are made to be compatible with the very old code. They weren't loaded, couldn't be dumped to this archive, but it was resolved, I think, with the Java 19 or something like that. So it's good to keep our JVM up to date. And moreover, Spring team is aware of this feature, and there are documentation, and actually they improved finally in Spring Boot 3.3.0, which will be released in a month or something. And it will have possibility to build finally exploded jar, which can be handled with system class loader. So finally, we can use class data sharing without custom scripts. Okay, again, the demo. Too fast. Class data sharing. Okay, so if you are using the Spring Boot under 3.2.0, then you need to pass some configuration which allows stopping your application when the context is refreshed. And it's quite easy to do. You need to configure the bin, which will receive the application context, and after that stops our JVM. For that case, our our Docker file will have additional flag for enabling this profile. When we are using Spring Boot 3.2.0, there was added flag to do the very same, to stop context when refresh is finished. So there is on the Spring Boot 3.2.0 or Spring Framework 6.1, there is this flag, and it produces the appcds JSA, which is then reused. And there is this flag xshare on. If there is an issue with loading this archive, we can stop starting the application. It's nice to do it on some QA dev environment to be sure that we are using this application and we don't invalidate the cache. And from Spring Boot 3.3.0, we have the new tool, the jar mode, not a layer tools like it was called before, but it is called tools, and it has the very similar flags. Let me run it. I need to rebuild application first. And it will be very similar output for the one produced by custom shell script. So let's go to the build, libs. It seems like okay. Oh, here it is. In the out, we have another time layers with the application, with all of our source code, with correct manifest, with correct order of the libraries, and with our code. And then we have another layer for the dependencies. And there are no snapshot dependencies, and there is no Spring Boot loader. It's no longer needed. So to build correct image with Spring Boot 3.3.0, it's also kind of funny. Let's run it first, and I will talk about. So here we are extracting our layers, and just after that, to build our archive with class metadata, we need to unpack dependencies and the application. We don't run these two lines as there is no data. And we need to add this cryptic P. It stands for the preserve timestamp. That's why, because CP changes modification time, and if we change the modification time, application on the subsequent run will fail when we add extra on. What's more, when we copy files from the previous stage, we need again be sure that all files have the correct modification date, because it can also, in unpredictable manner, because I had this code working correctly without this line previously, but today, before this demo and presentation, it doesn't work at all. And yeah, it makes sense to copy as a last step this archive, as it will change with every of our changes. Okay, so that's it. How many of you learned something new today? I think quite a lot. And right now we are on the topics from the conferences, and it's a bit late, I think. I did check the time. Yeah. So it's 70 minutes, so I will try to be a bit faster with these new features, as there are a lot of problems. So have you ever played on Nintendo or Pegasus in Poland? Do you remember this time when we got on Windows first emulators with possibility to make a save? Like, I played a lot with the Daisy, and Daisy was a very difficult game, and this lack of saves used to make me nuts. And there was a funny discussion on the internet when Nintendo was blaming these emulators that it breaks experience. Like for me, it gave a chance to finish some of these games, and it was funny. And the very same goes for the CRaC project in the Linux kernel space, which is basically doing the very same. There is a thing why we can't make a snapshot of the whole memory of our application, dump it to the file, and on the subsequent run, load it back and start it constantly. Then we should save a lot of time which we spent during the startup. And this project was implemented by the Azul with the name, nice name, CRaC, to make a checkpoint when we start the application on the some moment. And before making this checkpoint, we need to remember to close all our sockets, files, thread pools, and it's not finite. We should think about our credentials. We need to replace them with like a null, because if someone gets the memory snapshot, it will get the information to our data. And on restore, just after loading our snapshot, we need to recreate those. And since Spring Boot 3.2.0, I think, no, it was 3.10, the CRaC support was implemented. And under this link, you can check which projects currently support CRaC, where you don't need to write some custom code to handle these issues mentioned previously. And when we should make this snapshot, our application, on the y-axis, we can see velocity, like a throughput, let's say. On the x-axis, we can see the time. So when we start the JVM application, firstly, we interpret the code. After that, C1 compiler starts to compile the code, but it's not very efficient. And after that, C2, step by step, improves our code. So the best option is to make, like for this example, after 65 minutes of running this snapshot, and then we can reuse the archive, reload it, and start with the full throughput, like with solution with ahead of time. So there is a long comparison ahead of time. Probably you are thinking about the GraalVM, but the most important difference is speculative optimization if we think about the performance. But not really, because GraalVM is working to add speculative optimizations on the startup. I don't know how it will be done, or it's already working. And this is the only thing why we can stay still with JIT, because maybe we can be faster with from the GraalVM. If you would like to implement CRaC in your project, the best docs are not on the Spring framework or Spring Boot, but on the Azul. So this is the page. And finally, we are getting the place where the leaking abstraction is the Dockerfile. Project CRaC works only with the Linux operation system, not on the Windows, not on the macOS, and it could be a nightmare if we don't have implemented dev containers. And the very same goes for building it from the different platforms. So how to configure that? First of all, we need to add the dependency for the CRaC project. And there is nothing fancy more in our build script. There is a couple things which we can add to our project. Why the Gradle is not reloaded? Not. Okay. So first of all, we can add a controller, and when we are warming up our application, when it's done, we can call this method, and there is static method in the core class from the CRaC project, and then we can close our application. And when we have some objects which are not managed by the Spring, for any reason, we can handle life cycle by implementing resource interface. It gives us two methods. One, which is run just before the checkpoint, where we can here erase our password, and after restore, we can load it again. When we have a bin managed by the Spring, then we can implement smart lifecycle in such bin which managed, for example, thread pool or socket or credential. And on the start method, we are loading the password. On the stop, we are wiping it out. This is what could be done from the Java code. And after that goes nightmare. And it's basically nightmare. Yeah, we are going to the script for creating Dockerfile. Beginning is easy. We are using the JVM either for AMD 64 or for the ARM 64. Just after that, we are building our project. Then we are building Dockerfile, CRaC deploy, with argument to the one of these images, JDKs. And then we will go deeper. First, there is a description of the argument, where the JDK should be placed. Here is downloading the JDK through the internet. Then we have extraction, cleaning up. We are creating the place for the application. We are copying it. And then we are copying additional entry point script. And let's go further, third level of hell. We are loading place where should be placed CRaC files. Just after that, we are checking if it's already there. If not, it means we are the first who should produce it. Then we are make a magic to start the process with the number 128, because on the subsequent run, before the application starts, there are the processes which copy the data from the disk to the memory. And they could still be running when the application tries to run. And that conflict can cause a random phase of the application, not every time. So we need to think about that. Then we need to start our application here without warming up, just stopping just after refresh. After that, we are pointing where it should be written down files from our CRaC. And after that, we are pointing to the app. We sleep infinity, and we will see in a while why. And in the other case, we are just starting application based on these files. Surprise, surprise, we are not pointing again the app.jar file. We don't need it anymore because everything what is needed is on the RAM. And finally, we are trapping the signal for killing the application to pass it to the started one application. Okay, so come back here. And after build of that image, it's not here. Okay, it's over there. What we are doing, we are running this image in the privileged mode because CRaC requires access to the kernel space, which is not normally accessible for our application, to be able to dump a file. And this step is like feasible to done. I can imagine it's easily to talk with the team to be able to run our image, to build our image with privileged mode, because it's not exposed on the production, basically. And just when it will be, it is called CRaC container, CRaC container builder. We are waiting some time until application starts. And just after that, do you remember this slide where there was a commit and run? This is exactly what we are doing there. We cannot, unfortunately, in the Docker file, explain that the given line, coming back here, we cannot add a line describing, okay, I am dumping a file like it was done for the class data sharing, and reuse it in the following lines, because it needs privileged. We cannot add -- privilege there. So we need to add it. Then we need to change nothing. We are replacing entry point from this inside shell script to the very same shell script. We are finding the SHA number for this container, and we are commit snapshot of this container to the new name. After that, we are stopping this the first container. Okay, so let me run it. It will take a while. Oh, good, successful. So while it's running, we'll see how to CRaC. It was the name. Restore container. What we need to do on the production when we have this container with the dumped files, we need to add capabilities for checkpoint restore, system ptrace, system admin, and net admin. And there is the issue, because maybe our DevOps team can't agree to add these capabilities, because if someone will find another log4 shell, he will have the very same capabilities if he can take to the shell. So maybe it can take control of our container. Of course, there are also implementation like for the AWS Lambda, and I believe for the Azure Functions. So I think there, using the CRaC is pretty fine. I don't want to right now go deeper, and I think it will take too long with my current internet. So let me stop it to save your time. But if you would like to go deeper, you can run dev container and make everything on that. So that's like if you would like dev containers on your station. And what's more, these archives are huge. We'll see that later. We are closer and closer to the finish. So the next thing is ahead of time compilation. We have that for nothing, thanks to Spring Boot team implementing support for the GraalVM. It's about removing reflection on the startup time made by the Spring Boot application. But unfortunately, it has restrictions. What we are building, the configuration for starting our context is used in our builded file. So imagine you have some classes which are used on the given profile. And you have like 3 profiles, dev, QA, prod. And the different class should be used on every of each environment. Then you need to produce 3 application for every of these profiles. You need to produce 3 type of your images and so on. But startup of application is a bit faster. And this is quite easy if you have idea how to handle all of these issues. So with Gradle, you just need to add one plugin, and all the magic will happen behind. And finally, GraalVM. So I will go fast because it's 1.5 hours. I think it's too long, even for the good movie. I don't like longer ones. So GraalVM uses this ahead of time compilation. It gives us instant startup because everything is compiled. There is no warm-up needed. We can use low resources. We have reduced surface attack. When we think about the log4shell case, if we don't use in our code some parts, it will be wiped out if we are using GraalVM. That's not happens when we are using the JVM. All of our bytecode is loaded into the memory. And we can have nice compact packaging, which means here that our image could be small. And one of the sources of that is that we don't need to use JRE anymore. And that made me crazy. Last year when I was on the Spring I.O., there was a presentation for the supporting GraalVM in Spring Boot. And there was a survey made it in the early winter of 2022. And there was a question, which of the following frameworks are you using with GraalVM? And it was just after like 1 or 2 months after releasing production-ready support for the GraalVM, which is shitty. It doesn't work, for example, with the Kotlin projects. I don't know if the newest Spring Boot, I didn't make checks, but if you would like to use GraalVM with the Spring Boot, you need to switch back to the Java. So that was funny, but like 50% of the projects were using Spring Boot, even with all of that issues. And the projects which had supported GraalVM from the early days had less usage of that. And that's why I'm making presentation about Spring Boot and not about the Quarkus. Even if the Quarkus maybe is not the bad or micronode. And last for today, demo. I promise it will be fast. To support native GraalVM, we need to add plugin for that one, and it underneath works with the plugin from the Spring Boot. The very same goes for the Maven. What we need to do when we are using the ARM architecture, if we are using build kit, and here I think the build kit is very fine as these images are very thin and there is not a lot of things to be broken by build kit. And maybe here this is the good case to use it. This is the first side. If we would like to build it on our own, we need to use the image provided by the Oracle. And what is funny, they are not provide image supporting muscle. So we can't use here small images like Alpine. There are images for AMD64, but not for the ARM. I don't understand that because the documentation for the GraalVM says that there is no issue building muscle images with GraalVM. I don't understand that. And I'm not going to build these images because it will take a lot of time. Should I show anything else? Okay, you will have troubles with reflection, you will have trouble with loading resources, but everything of that is possible to be handled by Spring, by the annotation of Spring Boot, but when I prepared this presentation, I thought it won't be a time for that, and that wasn't a mistake. So finally, I promise it will be fast. I made some comparison of startup time for the Spring Pet Clinic with JDBC for PostgreSQL, and I would like to compare just a couple of the numbers. First, we have our Fedger startup time. It was like 1.7 seconds. Adding to that unpacked application with class data sharing, with ahead of time compilation, we can improve startup time by, let's say, it's very, very rough estimate, by 50%, let's say. But our image size increases about 50 megabytes. So we need to go and measure and check if it's faster on our production, unfortunately. With comparison with these brand new tools, which are shiny on current presentation, CRaC, yeah, it's very, very fast. It starts constantly, but the app size with CRaC files is 350 megabytes. It will take time to send it to the node, and I'm not adding there the data which is needed for the JVM. And currently, there is only Azul and Liberica who produce the images for the CRaC. And if you can, you should go that way. Fast startup time, small image, really small, no need of the JVM, just thick layer. And maybe in future, if you will be using class data sharing, you can use the Project Leiden, which will allow to add to this archive as well the bytecode, not only the code. Final comparison, if you would like to use just a straight JVM and improve your startup time, you need to use class data sharing ahead of time. If you would like to use CRaC, maybe on AWS function Lambda, it's reasonable to use. Maybe the nodes are run early in advance, and this snapshot from the memory is already loaded, so it starts constantly. But if not, it will take definitely the time. You cannot change that. And finally, GraalVM, yeah, it shines. If you can, you should go there. The issue is with the licensing. Currently, we can. I'm not a lawyer, but I believe we can use Enterprise Edition every half a year, the newest one. When there is a deployment, like Java 23 in the September, I guess, we should switch to the Java 23, and then we can use optimized performance, and there GraalVM shines. Summary. There is no silver bullets. We had to measure everything. We need to make choices for every single project. The only thing which is constant is the size matters. It's better to make it smaller. Here is my repository. Thank you. If you have any questions, it's a good moment.
I have a question, because you started with showing this Jigsaw approach with tailor-made JVMs basically for your needs. But it seems to go against the approach with Dockerfile, because you are tailoring your own JVM depending on the needs of your application. This means that you probably couldn't reuse it between different applications you deploy.
I will repeat the question. You started talking about shrinking the JVM with the JLink, and builded image won't be reusable with other projects, probably. And that's true. It will be. So if you can't produce the shrinked JVM, which can be reused by the different teams. Maybe it's not worth doing it, but maybe you can agree with what modules are needed, and you can make it smaller, but the smallest one image produced by Liberica. So it's still some room for the improvement. There's other case, reproducibility. You don't have any information from the JVM, but produced JVM, this new one, shrinked, will be the same every time. So it can have like a different size. It can have written down build time. It can have some paths. So maybe it should be run once, and then everyone should just point from the front file. But maybe it's worth doing that only for your team if you can't align. Finally, you should only measure and check if it improves the startup time or not. Have I answered the question?
Yeah, but still, if you have different images for different teams deployed in one cluster, then you can show.
Yeah, there is the answer. There is so many options that this comes with the beginning of my presentation, because if we don't have like aligned one way for improving the startup time, how we can start talking about like the right metrics? Here we need to measure, check, and in every company, in every project, we'll choose the different solution because of the environment, because of the people, because of the state of the art. Unfortunately, no silver bullet. Not thank you. Questions? Do you have any more questions?
Yeah, so you spent quite a lot of time discussing how to shrink the images only to then grow them with crop. But what I would try to do would not be trying to shrink the images, but trying to pre-warm the cache, Docker image cache at Kubernetes, so that I wouldn't have to download those images at all at startup time. Have you tried this?
My services are built on AWS ECS, and we don't have all nodes every time. So there was like a 5 seconds for looking as well the node which will be scheduled for us, and it has no cache. But if you can, that's amazing. Yeah, it's better to warm up the caches and put all of that data, and then CRaC looks great. You don't need to care about that. And what you need to think about, like I talked about the big events. If you have a surge event, probably do you have in your Kubernetes cluster all nodes, and can you add the new one in the very fast time manner? Because you will spend time filling this new node with the old caches from all your company, but at the time people would like to watch the Super Bowl. And you are still waiting because you are passing all of the caches to this node.
I think that there are solutions in AWS like S3 Extra Zone, for example, which is crazy fast.
It's crazy fast, but still you have limitation of bandwidth of the interface of the node and the network. So it still takes the time.
Then the approach is to get better networking for your nodes.
Yeah, we can go that way. And we can look the different solution.
Yeah. For the search events, definitely. I mean, I wouldn't probably do so for the regular, like single machine upgrade, but for search events, why not?
Yeah, definitely. Doing that for the events, and the moment when we know that we will have a surge of the events, we can start additional nodes and prefill the caches for them.
Okay, thank you.
Thank you. Any more? Okay, I understand it's late. Thank you very much for your time.